So most people know pi from the circle. So it tells us something about the ratio of the radius and the circumference, for example, of the circle. And this is what we all learn in high school. It turns out that pi has this sort of fundamental property that it relates that it describes the circle in some sense very well. If you have a sphere, then pi isn't very far. Right? So pi sort of captures the ratio of the volume to the radius, for example, and things like that. We have images that live on a sphere, and they come out of these fisheye cameras. So these are cameras that can capture sort of a very wide field of view. And that's very nice. If, for example, you have a car and you want it to park automatically, then the camera has to see everything that's around. And then, of course, you want to use deep learning to analyze those images. You need certain models that sort of work well with this spherical geometry. And, well, this is what we're working on, to sort of improve these and then to study the mathematical structures that sit behind this. I mean, the big goal in this is to say that, okay, we want to have some sort of theoretical guarantees about these networks. Because a big problem in deep learning is that a lot of it is very empirically driven. That means people just sit down, they try things, and then it either works, and if it doesn't, and if it works very well, then they publish a paper. And that has worked amazingly well in the past, but of course it's sort of quite an inefficient process because it's trial and error at the end of the day. And what we're trying to do is to sort of put some more rigorous mathematical formulations, analyses behind that will help you, for example, predict what will work well in a certain situation. And here we're talking about spherical symmetries of our data, so we can describe that mathematically, and then we can use those mathematical descriptions to improve the sort of neural networks that we are interested in and that we want to build. And then the hope is that this way we have sort of a more guided or more principled way of approaching deep learning.